Hello, in this video we are working through exercise 1 in section 6.1 on integration by parts. Hopefully by this point you have already tried to complete this problem on your own. Perhaps you have gotten a complete answer and you are just watching this video to check your work. So if you are doing that and you don't wish to watch the full video, let me just go ahead and tell you that the correct answer here is u equaling x squared and dv equaling x e to the x squared dx. Now let me show you why this works. First of all, remember from the written discussion just above this video that choosing dv to be only e to the x squared dx doesn't work because you can't integrate that. But if we include 1x in here, then the first thing to notice is that u times dv is equal to x squared times x e to the x squared dx, which is the same thing as x cubed e to the x squared dx, which is our entire integrand. So that is something to check off first, that u times dv does take care of the entire integrand here, this entire function that is in our integral. Now we need to make sure that dv is integrable, and of course u is differentiable, but we can differentiate anything, so that part's not hard. So to integrate dv, remember this is what we need to do in order to get v. So we are going to integrate x e to the x squared dx. When we are doing this, we are going to have to do a substitution for x squared. Now, normally this would be a u substitution, so we would let u be equal to something, but we already have a u in the problem. We also have a v. So I am going to introduce the letter w. So we're going to let w equal x squared. Then this means that dw is equal to 2x dx. The x dx is in our integral already, but the 2 is not. So I'm going to divide both sides by 2 to get that 1/2 dw is equal to x dx. So then when we come back to our integral over here, we're going to have the integral of e to the w 1/2 dw, this constant we can move out of the integral. So we get 1/2 integral of e to the w dw, and e to the w dw is definitely something we can integrate. We get 1/2 e to the w, and w is just x squared here. So we get 1/2 e to the x squared. So just pulling together everything that we have, u is equal to x squared. I'm just rewriting this from above. dv was equal to x e to the x squared dx. v we found was equal to 1/2 e to the x squared. This comes from here. And du, we're just going to differentiate u here to get 2x dx. Okay, so this is why it works here. To answer or to complete this exercise, really all you needed was that as your final answer. But this work here does show why it works. So if the problem asked to show why it works, then you could do this. If you are curious in completing the integral, I will go ahead and include this here, even though it's not required for this exercise. So if we are going to integrate x cubed e to the x squared dx, remember this was equal to the integral of u dv. So we have u times v. U is x squared, v is 1/2 e to the x squared. So we get 1/2 x squared e to the x squared. Then minus the integral of v du. So we're going to have the integral of v du. Again, simplify before trying to integrate. So we get 1/2 x squared e to the x squared minus the 1/2 and the 2 cancel. So we get the integral of x e to the x squared dx. And if you compare this integral to what we have up here, we have already evaluated that integral, so we do not need to rewrite this work. We can simply use what we have here. We know that that's equal to 1/2 e to the x squared. So this is equal to 1/2 e to the x squared from work above. So we have 1/2 x squared e to the x squared minus 1/2 e to the x squared, and as it's an indefinite integral, we will add c. So in conclusion, we have that the integral of x cubed e to the x squared dx is equal to 1/2 x squared e to the x squared minus 1/2 e to the x squared plus c. Now remember, this part was not necessary for this exercise, but in case you were curious, this is how you would fully evaluate the integral in this exercise.